thank you again, the Satcom Vision team for putting this session and panel together, and Profin for the sponsorship, and inviting Telesat as well to present at least our LEO part of the journey here. And for the benefit of others who don't know who Telesat is one of the largest satellite operators in the world today, and I'm talking to you from Canada, Ottawa, where we are headquartered. So jumping right into LEO, I think Hector did an excellent job of contrasting a LEO design and the risks or difficulties of doing a simple LEO versus a GEO. And when we started our journey a few years ago, that was a fundamental question we were trying to answer. We are technology agnostic. We wanted to build what is the best architecture to deliver data services for the enterprise customers. Telesat today and has for the last 50 years been serving the enterprise market from a data services perspective, whether it's telcos or whether it is other mobility service providers or the government market. And when we reflected deeply with both within ourselves and talking to our customers, definitely latency came out as a key concern. Not so much for latency only applications like gaming, but also more specifically for all the networks of moving towards, especially enterprise networks, so moving towards the cloud. And how do you enable enterprises to make sure their satellite networks also work as well and as seamlessly as their general fiber-based networks. But there were other disadvantages that, or other pain points that they had. For example, the aero and the mobility providers needed full global coverage in many use cases. Some of them wanted very, very high capacity density and so forth. So though LEO seemed to be an answer to get to there, the key risks still remained, and Hector pointed them out very well. How do you design a LEO system so that you do not have very low capacity density, and you are not forced, and you improve your sellable capacity, and you're not just forced with a lot of unsellable capacity over the ocean? So we had to solve for that. And the other thing we had to solve for a viable business case was not having a short lifespan LEOs. I mean, LEO is just orbit. You need to design properly for a viable business case. So a 5-year life satellite constellation didn't make sense to us to go over that way. So with all those factors in mind, and with that still focus on the enterprise market, we came up with our Lightspeed design, network design, which is primarily a constellation of 298 satellites at 1,000-kilometer altitude. And each of these satellites is highly flexible. Flexible in the sense the beams that are there on the satellites are completely steerable and shapeable, as well as the satellites themselves are not traditional bent pipes. They have onboard processing, which makes sure these are layered. These are almost like switches in space rather than mirrors in space. And we needed that so that you have the overall efficiency of the network. Satellites can light up as many as 135,000 beams, and you need that to get around the very specific specific risk that it did of not being able to not serve, for example, the oceans where the satellite is not able to see a gateway. So irrespective of where you are, whether you're the equator or the poles, you're always covered with at least 3 of our satellites, and in some locations as it will be much higher than that. And that's one other point the picture on the right that you see of how we've distributed the satellites as well, again, to make sure that the capacity is in line with demand. We are going to put a set blue orbits that you see here, but most of our satellites, 2/3 of our satellites, or 220, are going to be in those brown orbits or the inclined orbits, because that is where most of humanity lives, ships and planes serve, and so forth. So we've combined this coverage and capacity layer also to make sure that we are not putting a lot of capacity over the poles where there's not much demand. And finally, this is not just about a constellation. Customers want a network, not just a satellite. So we will also be interconnecting, building a global ground infrastructure, which will provide a fully managed layer 2 network for enterprises. When I say enterprises, it is telcos, it is service providers serving all fixed as well as mobile markets. So some ways in which we differ from other solutions that customers will have. For example, on the speed that we can deliver to a single location, we will go all the way from serving 1 megabit to a single site, all the way to multiple gigabits to a single site. And we need that because you have a wide spectrum of use cases. You have at the extreme end, you have large cruise ships or large remote communities that need multiple gigabits. But at the other end of the spectrum, you do have smaller merchant vessel ships, for example, that don't need gigabits of capacity. So the network is quite scalable to serve all those different kind of speed requirements. Low latency, as I've already mentioned, was a key driver, but high capacity or capacity density that was introduced was another critical factor, since these satellites can aggregate capacity. Either multiple satellites can put down capacity at a single location or aggregate beams as well very, very dynamically. We can put down multiple tens of gigabits over demand hotspots. For example, an airport which has about hundreds of aircrafts at a point in time will be seamlessly served by the network. Overall, we believe that we've come up with a design that is delivering the best of two worlds. It delivers fiber-like quality, but at the scale and flexibility that satellites offer. I've clarified the use cases that we intend to serve. So we've, as I mentioned, primarily focused on the B2B market, whether it's terrestrial, aero, maritime, or the government market, all segments that we serve today, all segments where we have very strong customer relationships. And we announced about a month earlier that we have chosen Thales to be our prime contractor to build the constellation. It's a $5 billion constellation. Perhaps I forgot to mention that we are also that these satellites also have 10-year lifespan, and they are this is a fully Ka band network. Just to show you some two typical use cases, for example, this from a backhaul perspective, we truly believe that once we make, as an industry, we make the satellite solution as plug and play and as seamless, the addressable market is an order of magnitude higher than or larger than what it is today, by making sure that a telco doesn't have to add additional boxes or do anything different than they would use a fiber backhaul. That would make their life much easier and expand how they use satellite solutions today. And we fundamentally see that happening with LEO and in all our discussions today with telcos. Another lens from a mobility or an aviation perspective, beyond low latency, aviation market especially is looking for high quality gate-to-gate connectivity. Gate-to-gate connectivity means you need to be able to serve routes that fly over the poles. you need to be able to serve when the planes are over large airports, and some of the airports can get quite concentrated with multiple hundreds of aircrafts. So so our network was designed to cover all these use cases so that the end passenger from an in-flight connectivity perspective stays connected irrespective of where they are. In terms of progress and where we are, we have one satellite today that we've launched about 3 years ago. We've done a number of technology demonstrations with very large telcos, as well as mobility and government players. As you see here, people have experienced latency in the as low as 18 milliseconds of round trip time, have demonstrated that user terminals or antennas can track and hand over very, very large throughputs, and also very new use cases like 5G backhaul have been demonstrated to work seamlessly with the network. This will be my last slide, where we've also, one of the large supporters of the Telesat Lightspeed program is also from Government of Canada, where for their universal broadband program, they've chosen Telesat Lightspeed as a backhaul solution, wherein the telcos in the country would be able to use the Lightspeed network to connect remote and rural communities and deliver a 50 by 10 internet service to the household, which is Canada's definition of high-speed broadband. And this is a trend that we are seeing where governments are increasingly focused not just on coverage, but also on the quality of the connectivity. For example, FCC in their Rural Digital Opportunity Fund, they highlighted latency as an important characteristic that is important for quality service. And they set a boundary of 100 milliseconds of latency. So we believe we've got the right architecture. We believe that over the years, working with our large vendor ecosystem, we've got into a design that not only serves our customer needs, but also closes the business case in a highly viable manner. And we would be starting services in 2023. And we are very excited in this journey. So I'll stop there.
Yes, that's great.
Thank you, Manik.
Yeah.
So we have questions coming in from the audience. The first one is from Oskan Kong. Do you see a market future for laser-based intercommunications between LEOs?
Yeah, that's an interesting use case that we are already working on. For example, we've been selected by DARPA, the group that invented internet, to use our constellation as a relay network, as a space-based relay network, and that is the fundamental architecture component that's being used there is the optical laser links in space. So this is one example of using optical links for space-based comms.
Thank you. I'll sneak one of my questions, if you don't mind.
Go ahead.
You've diverted from most other constellations in the sense that your constellation is actually two constellations. You've got the orbital, the polar constellation, and the inclined orbit constellation. What has pushed you in that direction and not a global inclined orbit constellation without the polar?
Mm-hmm. I don't think we've diverted from what others are doing. I think everyone calls it different things. Some call it shells, some call it orbits. Yes. The fundamental reason we are doing it, Hector, is to make sure that the capacity distribution is optimal. By putting all satellites purely in a polar orbit, you have 50% of the capacity over the poles. And unless penguins love to use the internet, we won't be able to sell it to them. So but the polar shell is very good for full global coverage. So hence we decided to split the constellation to make sure we have a coverage layer with the polar orbits, but a capacity layer with the inclined orbit. But to be clear, it's not two constellations. It is one network, and for the customer, it'll be seamless. They wouldn't know which satellite they're being connected to.
Correct. The next question is from Darren Walker. How will Lightspeed differentiate itself from Starlink?
Okay. Firstly, we are not focused on the consumer market, which is connecting households with antennas, because we believe the cost of the terminal to connect a household via LEO is still high and does not close a viable business case to do that. So being focused on, so that is one way we are different. We are not going after the consumer market, but even in the enterprise market, we believe that beyond the network capability, having priority spectrum rights is important and gives enterprise customers especially comfort in knowing a future fit, and there's no risk in having spectrum that works is important. And we are a Ka band network. Starlink is a Ku network from a user terminal perspective. And with most future constellations, whether it is large geo or MEO or us, all being Ka band, enterprises want interoperable terminals, and they want to have move to a future where they can put a terminal which is Ka band and use across networks. So ultimately, the customer will decide what kind of network they need.
Okay, the next question is from Dennis Moore. Looking into the midterm future, e.g. 10 years, your technology might be out of date. How do you modernize such a constellation? Do you orbit and replace each satellite? If so, what is the deorbiting strategy?
Okay, very good, and that completely agree. Technology definitely keeps refreshing itself. So as I mentioned, our satellite life is actually 12 years, but 10 years in orbit and 2 years to allow for deorbiting and so forth. And after that, we will replenish the constellation using the best in-class technologies at that point in time. I think the second part of the question was how do we deorbit the satellites? We've made sure that all the systems that require the maneuverability and the deorbit capabilities at the end of life have multiple levels of multiple nines of resilience built into it, because we want to be space responsible citizens as well.
Okay, there are many more questions, but I'll try and keep to the schedule. And if we have time, we might get to them in the panel. So thanks very much, Manik.